Hello everyone, welcome to my YouTube video on the input-output Leontif model. My name is Young. I'm a student in class CC16 linear algebra exercise. Today I'm excited to talk to you about the input-output Leontif model, a powerful economic tool that helps us understand the interdependence of different sectors or industry in the economy. In this video, I will explain the key concept of the input-output Leontif model, its application and limitation, in a concise and engaging manner. So wherever you're a student or just curious about how our economy works, I hope you'll find this video informative and enjoyable. Let's get started. Before diving into the lesson, let's take a quick look at the table of contents to get an idea of what topics will be covered. Now, let's begin by discussing the brilliant economist who developed this model, Leontif. The input-output Leontif model, also known as the Leontif matrix model, was developed by the economist Leontif in the early 1930s. Leontif was a Russian-American economist, a Nobel laureate who made significant contribution to the fields of input-output analysis and econometrics. Leontif developed the input-output Leontif model in response to the economic challenge of rate regression, when policymakers need a way to understand the complex interdependencies between different sectors of the economy. His model was based on the idea that every industry requires inputs from other industries in order to produce goods and services. By analyzing the flows of goods and services between different industries, Leontif was able to develop a comprehensive picture of the economy as a whole. Leontif's original input-output table was created for the U.S. economy in 1941, and it includes 42 industries and 3 categories of final demand: consumer goods, government goods, and investment goods. The table was based on data from U.S. Census Bureau and was used to study the effects of changes in government spending and taxation. Over time, the input-output Leontif model has been refined and expanded to include a greater number of industries and more complex economic relationships. Today, input-output analysis is widely used in economics, regional planning, and environmental science, among other fields. Moving on to the input-output model analysis, first thing first, I will give you guys a brief overview of illustrating the input-output matrix. Suppose an economic system has n different industries, I1, I2, I3 to In, each with input needs such as raw materials, utilities, and output, or the finished product. Introducing each output unit, an industry may use the outputs from other industries, include itself. For example, the petroleum industry utilizes output from different industries, such as coal, transportation, and even petroleum itself. Let Aij be the amount of the J industry need from the I industry to produce 1 unit of output per year. The matrix of the coefficient is called the input-output matrix, and we will denote it by the symbol A. To understand how to use the matrix, let's say that we have A23 equals 0.3, which means that 0.3 units of industry 2 products may be used to produce 1 unit of industry 3 products. If then A11 equals 0.2, then 0.2 units of industry 1 products is needed to produce 1 unit of its own product. Additionally, there are 2 commonly used methods for providing us with data for contrasting a matrix. Initially, it could refer to a table containing comprehensive information and data. We can easily recognize that in order to produce 1 unit of industry A output, we need 0.25 units from its supplier, 0 units from industry B supplier, and 0.38 units of industry C supplier. The output and supply standard for industry B and C are also determined similarly. Secondly, people occasionally provide you with a comprehensive set of numerical data instead of a table, and applying you to replicate the information in the table format. For instance, consider the knowledge acquired from those mentioned above. We can replicate an input-output table using the Leontif model as follows. The next step involves developing the problem further and implementing relevant formula. To develop the Leontif input-output model further, let the total output of the I industry try to be denoted by Xi. If the economic system is closed, meaning that it sells its products only to industries within the system, then the total output of the I industry is given by a linear equation. On the other hand, if the industries within the system sell products to non-producing groups outside the system, then the system is called open, and the total output of the I industry is given by, where represent the external demand for the I industry product. The following system of linear equation represent the collection of total outputs for the open system. Therefore, the matrix of the system is where X is the output matrix and E is the external demand matrix. We'll move matrix X to the left-hand side of the equation and factor out X as a common factor. Because X stands alone here, therefore we have to multiply the identity matrix I to perform the calculation. Then we have I minus A multiplied by X is equal to E. This is also the simplified formulation for calculating the external demand E for each industry. From there, we can solve for X by multiplying both sides of the equation by I minus A to the power of -1 on the left-hand side of both sides of the equation, as complying with the convention of this subject. That is, A times B is not equal to B times A. This is also the formula for calculating the output of industries. And after going through all the concept and detailed analysis, we now have a better understanding of the Leontif input-output model and have established the core formula of this model. Next, we will go to an example to give you a comprehensive look at what we have just learned so far. An industrial system with 3 industries, including petroleum, coal, and transportation, with the input requirements shown below. Find A, the input-output for this system. Then solve for the output matrix X, where the external demand for petroleum, coal, and transportation is 400, 300, and 450 respectively. We can derive the input-output matrix shown below based on the provided projection. To reduce $1 worth of output, petroleum requires $0.15 of coal, $0.25 of transportation, and $0.1 of its own. Therefore, A11 is equal to 0.1, A21 is equal to 0.15, and A31 will equal to 0.25, and we will do the same for coal and transportation. So we have A. Moreover, we can also extract valuable data from the aforementioned information, which is the external demand E. Here we have the identity matrix I as follows, since this is a 3x3 matrix. And with the data we have just obtained, we will find out the output X of each industry as requested. Recall the equation that we have just learned above. By substituting the identified matrices for variable, we have the following. After that is the computer chop, and we have the following result. To summarize, the output of 3 industries are $817.46 for petroleum, $641.43 for coal, and $905.24 for transportation. Besides this method, there are several other solution methods. By using the formula and substituting the matrices for variable, we have the following. And here we have 2 methods for solving this equation. First, we can apply the Gauss-Jordan elimination to solve this equation and have the following result. Second of all, we can use Cramer rule. Since our matrix is a 3x3 type, I will provide Cramer rule formula for a 3x3 matrix. Returning to our problem, we have, and let X be the form. Therefore, we will have the equation, and we can write it as Cramer rule, then calculating the determinant of A, and applying the formula, and we will have the exact same result as the 2 previous mentioned methods. Regarding application, the input-output Leontif model has a wide range of applications across a variety of fields, including economics, engineering, environmental science, and regional planning. Some of the key applications of the model include: first of all, it's also the most visible application, the application that we have just learned above, interdependency between industry. The input-output Leontif model provides a valuable tool for understanding the interdependency between different industries in an economy. By analyzing the flow of inputs and outputs between different sectors, the model can provide insight into a ripple effects of change in one sector on the entire economy. Similarly, the input-output Leontif model can be used to assess the impact of economic policies, such as changes in government spending or taxation, on different sectors of the economy. It can also be used for environmental analysis. To illustrate, the model can be used to estimate the carbon footprint of different industries, or to analyze the effects of environmental regulation on different sectors of the economy. While the input-output Leontif model is a valuable tool for analyzing the interdependency between different sectors of the economy, It is essential to be aware of its limitation that could impact its applicabilities in certain situations. Firstly, the model lacks temporal dynamics and assumes that the input and output coefficient remain constant over time. This assumption may not hold true in cases where technological advancements. This means that the model may not be suitable for analyzing long-term policy changes or dynamic economic systems. Additionally, the input-output Leontif model does not consider labor market dynamics, such as changes in wage, employment levels, or worker mobility, which may affect the relationships between different sectors of the economy. Last but not least, the input-output Leontif model is designed to analyze the interdependencies between different sectors of the economy at a nation or regional level, and may not be suitable for analyzing smaller-scale economic systems or for analyzing the effects of regional policies. By understanding all about the strengths and limitations of this model, we can make better decisions about how to apply it to real-world economic challenges. The Leontif input-output model has many applications, and despite its inherent limitations, it remains one of the most significant inventions. As you can see on the slide, I have listed a number of references that I consulted as I researched this topic. These sources include books that help me to gain a deeper understanding of the subject matter. Thank you for watching this video about the input-output Leontif model. I hope that you will find this overview helpful in understanding the key concepts, applications, and limitations of the model. If you have any questions or comments about the model, feel free to leave them in the comment section down below. And if you enjoyed this video, please don't forget to like, share, and subscribe for more informative content on linear algebra and other related topics. Thank you again for watching, and I'm looking forward to see you in my next video.